Hello, welcome back. In this segment, I want to show you an interesting problem due to unsigned integer arithmetic. So consider this little function string longer that takes two pointers, s and t, and it returns either true or false, of course, because there's a greater than check. It checks the string length of s and checks the string length of t. If s is greater than t in terms of the string length, it returns 1, right? Okay, otherwise it returns 0. So the possible values that will come out from this function is either 1 or 0, right? These are the possible values. Similarly, we have another function, string longer. This is the version 2. Mathematically, these two appear to be the same, right? We say a is greater than b. This is same as a minus b greater than or equal to a minus b greater than 0, right? Okay, these two are equivalent in math. So if you go by that reasoning, there should be no difference whatsoever between these two functions. They should be called identical or equivalent functions, right? But it turned out that is not the case. Let's understand why. Okay, why don't we directly compile and test and see if we can break the assertions here. So I'm asserting these two functions are equal, right? I'm calling the function with two arguments, right? arg1 and arg2. arg0 is not important because it's the name of the binary. So we store the result in test1, and then we do the same with the second version, store it in test2, and we are checking whether these two are equal. Let's try whether these two are equal by just some examples. Okay, let's do that. Let's get out and compile and see what happens. So I will compile this code, right? String longer.c. No failure in assertion because hello has 5 characters, fun has 3 characters. So both version, right? You can look at the both versions. They behave equivalently. Okay. Therefore, they both return the same return code. So assertion passed. But let's change the argument into fun hello. And now you see assertion failed. Okay. Let's go to the code and understand why. Fun, the string length of fun is 3. String length doesn't include the null byte, so it's 3. For hello, it's HELLO 5. 3 greater than 5 is wrong, so this function returns 0 to the caller. So result must be 0 here. And what about string longer version 2? Version 2 is interesting. This is 3 and this is 5. What is 3 minus 5? 3 minus 5 is actually minus 2, but there is a catch. String length function actually behaves in an interesting way. It's not returning integer, it's returning a size underscore t. Let's look at the definition of string length very quickly, at least the syntax. Okay, you can see string length returns size underscore t, which is usually unsigned integer type. Therefore, what happens here is that we are subtracting 3 and 5, right? 3 minus 5, which is -2. But then, because this is an unsigned integer, this is an unsigned integer, subtracting 2 unsigned integer is always an unsigned number. -2 is a huge number, actually. In terms of binary, it will be like 31 once and then a 0. Okay, that's the value that will become extremely large because it's interpreted as a unsigned integer, right? And that very large number is always greater than 0. So this is going to be also, this is going to be 1 and this is going to be 0. Okay. Okay, both versions actually return 1 or 0, but this version returned 0 because 3 greater than 5 is clearly wrong. Here, 3 minus 5 is a very large number, positive number. Therefore, the positive number is greater than 0 is true. So this is returning 1. So we have 0 here and 1 here. Therefore, the assertion failed. We can compile and debug and load it into GDB and check that, as always. Okay, let's do that. We can just load it into GDB. and run. Let's disassemble the main function, right? Okay. We can do one more thing. Let's compile this code again with the compiler flag turned on to make it easy for us to investigate. It's not recommended in production, of course, otherwise the whole code will be part of your binary. I'm going to use this for my debugging purpose. Okay, I'm going to put a breakpoint at line number 20 and run with input fun and hello. Test 1 should be 0, test 2 should be 1. That is my climb. Let's do that. Okay, we can print test 1. Yeah, it's 0, it's 1. Therefore, the next statement will fail, assertion fails. Okay, the reason is simple. The reason is we're subtracting two unsigned numbers. If you subtract two unsigned numbers, the result is always an unsigned number. Unsigned numbers are always either greater than or equal to 0. Therefore, this is perfectly failing for the case when first input is actually smaller than the second input. Okay, if the inputs are same length, of course, both program will return 0. Okay. All right. So that's basically it. So be careful when you're using unsigned during the arithmetic operations. You may be surprised by these kinds of small mistakes that can lead to security problems at times. Okay, thank you. That's all.